Hello and welcome to Tribe Topper. In this video session, you are going to learn about heat and temperature and how they are related to each other. If I ask you in the most simplest terms, how would we define heat? We would say heat is a form of energy which produces in us a sensation of warmth. And of course, it flows from a hot body to a cold body. So as you know, I have shown here a cup of tea. So when it's winters, we want to feel that sensation of warmth. So we take a hot cup of tea. So that means heat is producing a warmth inside us. But as you can see, these arrows say that this heat is going to go to the surroundings because the surroundings are colder than the cup of tea. So the heat will be lost to the surroundings. So that is why we would say it flows. It's energy that flows from a hot body to a cold body. And what is temperature? So I've written here two definitions. Degree of hotness or coldness of a body. That's temperature because it tells you how hot or how cold a body is. But otherwise, as in this grade, you are going to learn about the particle model of matter. And as you all know, that all matter is composed of the atoms. And here, like we have solids, or I've just drawn a liquid, not solid. So what would temperature tell us? Like, I think you can imagine that if you increase the temperature of something, all these particles, they are going to run around and become very energetic. So that means we would rather define temperature as a quantity that determines the average kinetic energy of the particles in an object. So all the particles that are constituting that object, if they have a higher kinetic energy, that would refer to the high temperature, because that means we are giving it heat which is going to be converted as the kinetic energy of the particles. So either we can say it is degree of hotness or coldness of a body, but that's a very basic definition. For grade 12, you need to understand, you will define it rather that temperature is a quantity that determines the average kinetic energy of particles in an object. And temperature is a scalar quantity. So we measure it in these two units, Celsius and the Kelvin scale, using a thermometer. And I'm sure you all know that we use a thermometer to measure the temperatures. So we have a mercury thermometer. So you can see here, if this rises, the level rises when the temperature is higher. So this goes on expanding. And what is the principle of thermometer? The expansion of the liquids, right? So expansion on heating. So something is at a normal temperature, mercury is lying at some point, and the moment we have a higher temperature, the mercury will expand and it starts rising. So it tells you the temperature around you. We need to understand that, as we said, heat energy, it passes from the hotter object to the colder object, but till what time? Until they are both at the same temperature. So if I say I have a body at a temperature T1 and I bring in contact another body which is at a temperature T2, immediately the heat would start flowing from this body, hot body, to the cold body, if I assume that T1 is greater than T2. So the heat will keep flowing, but till both of them, they reach a same temperature. Let's say they both reach a final temperature T. So that point of time, when the temperature is same of the two bodies in contact, we say thermal equilibrium has been reached, because equilibrium always refers to no more motion. So nothing will flow now. So heat flow will stop because now they are in thermal equilibrium. They have both acquired a same temperature, because heat can only flow from a body at higher temperature towards the body at a lower temperature. But if they are both at same temperature, then how will the heat flow? That means they are at thermal equilibrium. No more heat flow will happen. And another very important term here is absolute temperature. So just to let you know that 0 degrees Celsius, we don't call it as absolute zero. This is not absolute zero, because your temperature can still go to -10, -20, and the motion continues. But finally, when we reach as negative 273 Kelvin, negative 273 degrees Celsius, that is a temperature at which all the molecular motion ceases. We call that as the absolute temperature. So I'll define again. Absolute temperature is the temperature at which all the molecular motion ceases. And so the absolute zero is actually 0 Kelvin, not the 0 degrees Celsius, because at 0 degrees Celsius, you already have it in Kelvin as 273 Kelvin. So it's not absolute zero. But when we reach at 0 Kelvin, your temperature is minus 273 degrees Celsius. So we can always use this conversion. So if you have some temperature in degrees Celsius, you just have to add 273 in that to reach your temperature of Kelvin. So if I would say I have a 27 degrees Celsius temperature, then that would be equal to 300 Kelvin. In the later videos, I'll tell you when you would need these conversions and when you don't need to convert. So that's all for this video session. In the next video, you are going to learn about the particle model of matter.